Okay, so let's look at multiplying and dividing rational expressions. So we're going to do some fraction review. So when you do multiply fractions, you're going to multiply top times top, bottom times bottom. So we're going to do 4 times 2 is 8, and 5 times 3 is 15. And then we look, can we reduce? If we can, then we do. If we can't, then we're done. So in this case, 8 and 15 don't reduce, so we're done. Same here, we're going to do top times top, bottom times bottom. So we're going to get 6 over 28. I can divide both the top and the bottom by 2. So I'm going to get 3 over 14. If I look at division, when we divide fractions, we invert and multiply. So what I'm going to do is I'm going to write down 3 over 5 times 4 over 1. And then I can do top times top, bottom times bottom. So that will give me 12 over 5. And then I look, can I reduce? We have 12 and we have 5, and they don't reduce. If I look at this one, I have 2 over 15 times 10 over 3. So I invert and multiply, top times top, bottom times bottom. So that will give me 20 over 45. I can divide top and bottom by 5, which will give me 4 over 9. So again, let's look at moving along to multiplying rational expressions. So again, to be able to multiply them, they absolutely must be factored. So if I look at this one, the top and the bottom are all factored. So I'm going to multiply top times top and bottom times bottom. So I'm going to multiply 2 and 5, which will give me 10. And then I have the 2 brackets. So top times top, bottom times bottom. Now I can reduce. So I have a bracket here and a bracket here that are like terms, which can simplify and cancel out. Then I'm left with x plus 4 on top, x minus 1. And on the bottom, 10x minus 2. Again, when we state restrictions, we restate it for the entire bottom. So if I look at this, 10 does not have an x attached to it, so there's no restriction on that. So I have x plus 1 and x minus 2. So x plus 1 cannot equal 0, so x cannot equal minus 1. And x minus 2 cannot equal 0, so x cannot equal 2. So the restrictions are that x cannot equal minus 1 or 2. If I look at this one, I check, is it factored? No. Then I do need to factor it first before I can multiply it. Reason why I know it's not factored is because there are plus signs between the terms. There needs to be multiplication between them. So if I look, I can factor this. I end up with x plus 3 and x plus 4. On the bottom, I have, looking for a common factor, I have a common factor of 2x squared, and I'm left with x plus 3. Then I can multiply that. There's a common factor of 6x, and I'm left with x plus 3. On the bottom, it's a difference of squares, x minus 4 and x plus 4. Again, I multiply top times top and bottom times bottom. So I'm going to move the 6x in front. I have x plus 3 and x plus 3. I can write them separately or I can write them squared. I tend to write them separately so that I don't get confused or mixed up. And then on the bottom I have 2x squared, x plus 3, x minus 4, and x plus 4. So there's a common factor. There's common and that we can cancel and simplify out. I have a 6 on top and a 2 on the bottom. When I divide, I'm left with 3. I have an x on top and an x squared on the bottom, which means I'm left with x on the bottom. I can divide both by x. That will cancel that out, and that will leave me an x there. I have an x plus 3 that's left, and here I have an x minus 4. Again, I need to state restrictions. Restrictions are stated from the bottom, and they are stated on the original equation. So I have a 2x squared. In this case, because I have that x, I have a restriction. So I have 2x squared cannot equal 0. X cannot equal 0. Next one is x plus 3 cannot equal 0. So x cannot equal minus 3. Then I have those two. X minus 4 cannot equal 0. So x cannot equal 4. And x plus 4 cannot equal 0. So x cannot equal minus 4. So now I need to state restrictions on the final answer. So x cannot equal 0, minus 3. And because there's a both plus and a minus 4, we say plus minus 4.